Welcome back to PreAlgebra with Miss Betsy. Today we are going to be talking about congruent triangles and congruence properties. The text that I'm using today is the first edition of PreAlgebra for Christian Schools, published by Bob Jones University Press. Doesn't matter what text you're using as long as you are interested in finding out about congruent triangles. So let's go ahead and pray, see our lame joke, and get started then. God, I thank you that you love us. I thank you for the constant reminders that you are right here with us. And I thank you for the beauty of the spring around us. Lord, I ask that you would help us to keep our minds focused on our studies this day and to accomplish the things that you desire for us to accomplish. And we give you all the glory in Jesus' name. Amen. Okay. I just went up to take some things up to my trash. My roosters followed me the whole way up and the whole way back, wanting to have something to eat, so I got them their scraps. And you know what they were fighting over? They were fighting over the leftover pork chops. Just like they love scrambled eggs, and they like chicken meat as well, which I think is just so wrong. But along the lines of animals, can you tell me what it is that a rabbit uses to keep its fur in place? Well, that rabbit uses hairspray. Okay? We have two triangles here, and these triangles are labeled, are identified by the points of their corners. This would be triangle ABC, and you would indicate it by drawing a triangle, shape, triangle, and capital letters. Capital A, capital B, which I cannot draw right now, ABC. And then we have a second triangle down here, and this is triangle DEF. And we could say BCA, CAB, CBA, but typically when you're labeling things in algebra, you're going to use them in alphabetical order. So we have triangle DEF. And I have this monster triangle pattern that I got to use in class. It really is extremely ineffective. I'm going to return it. But this is the pattern that I used to draw both of these triangles. So they're going to be they're supposed to be the same dimensions. And what you see is we have the triangles, they have the same size and they have the same shape. And these are then called congruent triangles. Congruent triangles have the same size and they have the same shape. They may be oriented differently. These happen to be oriented in the same way, but they're going to have the same size and they have the same shape. And when they have that same size and the same shape, we say that those are congruent triangles. And we are going to use the symbol for congruent with an equal, and then that squiggly line that we usually use to represent is approximately equal to. So triangle ABC is congruent to triangle DEF. And if you would go ahead and pick up triangle ABC and set it down on top of triangle DEF, you would say that they would fit. Theoretically, they're going to fit because they're the same size, same shape, same orientation. And you would see that the corresponding sides would be the same and the corresponding angles would be the same. And if you look in your text, there's a lot of vocabulary. I told you chapter 11 is lots and lots of vocabulary when we're doing this geometry. It says the angles, the matching vertices. Okay, the angles at the matching vertices. This vertex A, vertex B, vertex C. Vertex is one vertex. If you have more than one, it's like the Latin plural vertices. It's not vertexes, it's vertices. So the angles at the matching vertices are going to be the same. The length of the sides are going to be the same. And they're called corresponding. So angle A and angle D are corresponding angles. Angle B and angle E are corresponding angles. Angle C and angle F are also corresponding angles. Line segment AB is corresponds to line segment DE. So this is corresponding angles, corresponding sides are congruent. Corresponding angles, I said angle A, angle A corresponds to and is congruent to angle D. Angle B is congruent to angle E. Angle C is congruent to angle F. Corresponding sides, corresponding angles, they match. When they match, they are congruent. Okay, corresponding angles have the same measure. This is a 45-degree right triangle, which I wouldn't expect you to know. But these angles right here are 90-degree angles. They have the same measure. These angles here are 45, so angle A is a measure of 45 degrees. This is a measure of 45 degrees as well. And that would be the way that those angles work together. See, to indicate that corresponding angles have the same measure and corresponding sides have the same length, they're going to mark corresponding pairs with the same angle. So if we have, with the same mark, triangle ABC is congruent to triangle DEF, right here, angle 1, or angle A is congruent to angle B. I'm sorry, I misspoke. Angle A is congruent to angle D. Angle B is congruent to angle E. Angle C is congruent to angle F. So you see they're real creative here. 3 angles, 1 hash mark, 2 hash marks, 3 hash marks. Same thing with sides. Side has 1 hash mark. The second side that's congruent to this second side angle of line segment EF, that gets 2 hash marks. This gets 3 hash marks. Congruent triangles, they have the same size and they have the same shape. Corresponding angles have the same measure, which means they're congruent. Corresponding sides have the same length, so they are congruent as well. So I want to go ahead and sketch example 1 for you. And I have another worthless triangle pattern here that I want to draw this time. So it's going to take me a moment to get this drawn. This is what it would be so very, very nice if I had a pause on that remote. Unfortunately, I don't. And this triangle cannot be drawn very neatly. Such a total waste of money to get these. But there I have a triangle. Look at that. Ah! Put the triangle this way. Different orientation. But you're seeing that I am clearly using the same pattern. Attempting to use the same pattern. And we now have 2 triangles that are drawn here. Let me see how they want to do this. RST, XYZ. R, S, T, X, Y, Z. And we're going to assume that these are actually true triangles where where they have a point at the end. R, S, T, X, Y, and Z. So we have two triangles here. We have triangle R, S, T, and what are we going to say about it? We're going to say it's congruent. What does it mean when I say that that triangle is congruent? Because they don't look the same, do they? At least on the first two triangles we had, they looked the same, but this is X, triangle X, Y, Z. But I'm saying it's congruent, and what does it mean when two triangles are congruent? It means that they have the same size and the same shape. Same size, same shape, because I drew both of these triangles using this pattern right here. The orientation is different. These are what they call mirror images of one another. That's the orientation. The orientation does not have to be the same. Matter of fact, when you're working with congruent triangles, the orientation is basically never going to be the same, except when they force it, it to be the same because they want to teach you. So, if these two triangles are congruent, angle R, actually let me go ahead and write this in here. We have, I want to do the exact pattern that they're using. Remember, we're going to use hash marks on the sides and hash marks, well, I showed hash marks on the angle. They're actually going to use extra lines. There's a single line. Angle R and angle X are congruent. Angle S and angle Y. And they're putting 2 marks there. And 3 marks down at this corner angle. I have no problem whatsoever if you just do a single angle mark with 1 hash mark, or 2, or 3. Either one of those symbols of notation would be just fine. Example number 1, they tell us that triangle RST is congruent to triangle XYZ. So they want to know 3 pieces of information first. Angle R, angle S, and angle T. What are these 3 angles congruent to? Now see, if you just looked at this, I don't have a clue what they're talking about. But you already know that, oh, they're just looking for the matching angle. And here's our picture. There's one line here. There's one line over here. So angle R is congruent to angle X. It's important that you use the right notation though. Don't write angle, write your marks like I'm writing. Angle S is congruent to angle Y. Angle T is congruent to angle Z. What does that mean? It simply means that the angles have the same measure. R, Y, and T. Now they have 3 more pieces of information where they're using line segments, and they're going to go RT, RS, and TS. RT, RS, TS. You need to put the straight bar above that because that's what indicates it's a line segment. It's not a ray, it's not a straight line. This is a line segment that begins at point R and stops at point T. So line segment begins at point R, stops at point S, and a third segment that begins at point T and stops at point S. And they want to know what these segments are congruent to. And you know what they're congruent to, not because the shapes look the same or because the shapes look different. You know that they're congruent because it says the triangles are congruent. Congruent triangles, the sides are the same length, the angles have the same measure. And they've marked for us which sides are congruent. So line segment RT is going to be congruent. It has 2 hash marks. It's congruent to this one. To line segment XZ. Is it true that it's line segment ZX? Yes, it is, but let's put these things in alphabetical order. Now we have line segment RS is congruent to line segment XY because we have 3 hash marks here. And our final line segment, TS, is congruent here to line segment YZ. Haha, I love it. They put ZY. It is still standard to put things in alphabetical order. If you put them differently, it's not going to make any difference in how you read it unless it's array, and we talked about that in class last time. Because with array, you have one beginning point, and the array continues on forever in the opposite direction. Okay, let's read this. 2 congruent triangles have 6 pairs of congruent parts. However, you can use the following congruence properties to show that 2 triangles are congruent without showing that all 6 corresponding parts are the same. These are congruence properties. You must learn these. It is not hard. There are only 3 of them. And here's the shorthand for them. Congruence properties. This is how you determine if triangles have the same size and the same shape. Side, angle, side, angle, side, angle, side, side, side. A is angle, S is side. All right? What are we talking about when we have these? Side, angle, side is 2 sides and the included angle. We have 2 sides and the included angle. The included angle is going to be the vertex. So let's say that you have this triangle here and you have this triangle here. And you look at that and it's clearly not sketched the same. If I tried to do it very carefully freehand, I still wouldn't have it sketched the same. But let's say that it said this. Those 2 triangles are congruent by the side angle side congruence property, because look, we have the angle is the same measure, this side is the same measure, and this side is the same measure. This is what we talk about. Side, angle, side, 2 sides, and the included angle. If they're congruent, the entire triangle is congruent. Now, we have angle, side, angle. Let's have these 2 triangles here. Angle, side, angle. We have a side in between the 2 angles. You can't say angle, angle, side. It has to be angle, side, angle. If angle, the included side, and the second angle, if they are congruent, then the 2 triangles here are congruent by what they call the angle-side-angle congruence property. So we have two examples now. This third one is side, side, side. If all three of the sides of a triangle have the same length, are congruent to one another, then the triangles are themselves congruent. This quick little sketch here shows me two triangles that are roughly the same, but this tells us that this side is the same, that these two sides are the same, the hypotenuse are the same. I think it's hypoteni, but I've never heard anybody use it. And the base of the triangle, they all have the same. So these two triangles are congruent by the congruence property side, side, side. You don't have to prove that all 6 parts of the triangle are the same. You only have to illustrate 2 sides in the included angle, 2 angles in the included side, or 3 sides. Now, maybe some of you are saying, hey, Miss Betsy, there's another relationship that we can do here. And there is, isn't there? What is it? Well, it's angle, angle, angle. If we have 3 angles that are the same, doesn't that mean that the triangle is going to be the same? Some of you know about a 45-degree right triangle. One of those angles is 90 degrees, and the other 2 angles are 45 degrees. Matter of fact, that's what I said that this triangle was. It's a 45-degree right triangle. Well, shouldn't it be that if the angles are the same? No, you know exactly where I'm going, don't you? Here is another 45-degree right triangle. The angles are the same, but the sides can be teeny tiny or they can be gigantic. So, angle, angle, angle is not a congruence property. But if you have 3 sides that are the same length, that forces the 3 angles to be the same length. So that is the end of section 11 point, whatever it is that I was doing, section 11.7. There really isn't a whole lot more value in me showing you some more examples. It's simply vocabulary. Learning your congruence properties and being able to look at triangles that are oriented differently and figure out which sides are the same and which angles are the same. So that would be the end of section 11.7. Oh, this is funny. I think I've been saying this is section 11.7. This is actually section 11.8. Congruent triangles. It was supposed to be 11.7. Section 11.8, congruent triangles. Send me a text if you need help. I'll talk with you next time.